Hi everyone, and welcome to another lesson. And this time around, we are talking about factorization, and factorization is the first topic in Form 3. So, we begin this term by learning factorization. But before we start factorization, we just have to remind each other where we're coming from as far as factorization is concerned. Because factorization is simply a way of breaking down an expression into its factors. So when one defines it like that, we have to see how we can do it. So let's say 4, for example, as a number. 4 can be rewritten as a multiplication of two numbers. So let's talk about the whole numbers that we can write 4 as. So for example, I know that 4 is the same as 2 times 2. One would also say that the same 4 is 4 times 1. So essentially it's the same thing. 2 times 2 and 4 are the same thing. It's just that the 2 times 2 has broken down the 4 into smaller numbers that are multiplying each other. It's also the same as 4 times 1. So what we've done right here is what is known as factorization. So you use factors to write a number. So in this case, 4 can be rewritten in this way. We can also consider other examples like 8. There's a way of writing 8 using its factors, and 8 can be written as 4 times 2. Or someone would even say 2 times 2 times 2 is the same as 8. One would also say 8 times 1. So all of this is a way of factorization. So you just have to know the number and its factors, and then you're able to factorize. So this is factorizing expressions that are numbers. So you remember expressions are just a way of writing terms in mathematics or expressing something. So you should also understand that expressions are any mathematical term that can be used to mean something. For example, when we talk about 4 as a number, 4 could mean 4 cars, would mean 4 houses, 4 would mean 4 people, 4 would mean 4 eggs, 4 would mean 4 guavas. Actually, it would mean anything. It's expressing something. So in mathematics, 4 is an expression, but it's not the only expression that you will ever come across. You'll come across expressions like A, expressions like B, expressions like C, expressions like D, expressions like 4A, 4D, X, 2X, X squared, 5X. Any letter that you can think of, even if you combine two letters, they're expressing something. So what's that thing that they're expressing? So in this case, these letters in algebra are expressing a number that we don't know. So for example, X in this case, X would be a 5, would be a 2, would be a 3, would be a 6, would be 100, it would be a 0.5, it would be a half, it would be a 0.29. It can be anything. At the moment, we just don't know what X is, we don't know what C is, we don't know what B is, but we understand that behind it, there's a hidden number. Behind all of these expressions that we are talking about, there's a number hidden, and we just don't know it. So there's a way in which these expressions can also be factorized, So before we also talk about the factorization of algebraic expressions like C, D, 5x, x squared, a, b, 4a, 2x, and all of this, we have to understand that expressions can come in different forms. So for example, these expressions can add each other. So let's talk about 4x plus ab. It's also a way of expressing this. And even if we can collect D and C and we add them together, we can create new expressions. For example, C plus D as a new expression. We can also create another expression like x squared, this expression that we have here, and we subtract it with AB. So these are all kinds of expressions that we can come up with. And I can even give you an exercise to actually come up with an expression that you want. So you can just guess anything that you can think of. So for example, x squared plus x is an expression. So to come up with this expression, we have used x squared, we have used x. And also one would think of another expression. For example, if I was to also give you an example of expression, examples of expressions, let's say a squared plus b is my first example. My second example would just be x. My third example would be x plus x squared plus b. You know, all of these things that we are adding together are forming up expressions. For example, there's x squared, there's b. But what is very important for us to also know is that these are the terms of the expression. Like you saw that different expressions like x squared would come together, and once they come together they would add, for example, x squared and x would come together. I would also add with any expression, and you know, you can elongate this, you can extend it as much as you want, and all the expressions you want in the world can actually add each other. And this actually brings us to another important discussions where we talk about like and unlike terms. So whenever we have an expression made up of different items that are coming together, these items are called terms. So they don't always have to actually add, because this could actually be a subtraction, as long as there is either a subtraction or addition or a combination of both of them. That's when we have an expression like that. And we should understand that some of these terms within the expression are like and some of them are unlike. So what I like to think about is, when we talk about the like terms, these are the expressions that have the same letter. So what we mean by the same letter is that they are technically the same in the same family. For example, when we have an x in this case, we also have to look for an expression that has a single x. And according to me, there is this 2x that has also a single x. So the x is like almost like the surname, you know, how people have surnames. So this 2 has a surname and x. This negative x has a surname and x as well. It's a bit different from this one because this one is an x squared. You know, it's an x squared. It's different from x. It's like some people have surnames like Malunga, others have surnames like Maluwa. You know, they may have the same kind of beginning, but they have the different ending. So I can actually single out this doesn't have a like term, while this negative x has a like term here. Now let's talk about this a. Does it have a like term in the expression or not? I cannot see another expression with a single a. You know, this one comes closer, but it's not, because there's an AD, you know, so it's not the same. But there's a B here and there's a 4B here, because both of them are B's, single B, then they are like terms. And what you should know about the like terms is that they can add or subtract each other. So what I'll do is regroup our expressions. So in this next thing that we'll talk about, we will regroup expressions so that we can actually work with them, because the like ones can add each other. And so for example, if you tell me to regroup this expression that we have right here, I would just move them around so that maybe the negative x and the 2x are standing or placed next to each other. I will rewrite it so that the b here and the 4b are placed next to each other so that we can see them and we can rewrite them. So I will leave this the way it is because it doesn't have any like terms. And then when I am rewriting this negative x, I will rewrite it, but bearing in mind that there's another term right here with the same, which is like. So I will shift this next to the negative x. So in the next phase, I will write the 2x next to the negative x like that. And then I'm done with the x's. I have to actually write this one. So this is negative a. But I'm supposed to also look if there are like terms within the expression, but there isn't. I don't see another single a here, so it has no like terms. And then it's the turn for the b here. So the b has to be written, but we had already discussed that there's another term with a b here. So I'll just put it next to the b. The 4b will come there, and then we also have to consider this negative AB. Bear in mind that I'm actually considering it as a negative AB because it's not just AD rather. I mean AD. It's not just an AD, but it has a negative. So as I am writing it here, I have to bear in mind that it's a negative AD like that. Does it have another term like it? I don't think so. And then we have already written this, and we have also already written this. So this is where we are. The like terms are next, the like terms are next to each other and next to each other. So one thing that we should also know is that the like terms are able to add or subtract each other. So like terms can add or subtract each other. Subtract each other, just like normal numbers. So in this case, if we have like terms like this and this, so this is a minus x, we add it with 2x, we'll treat them the way we treat negative 1 plus 2, because the answer we get, we'll just give it an x at the end. So I'll rewrite the expression. There's an x squared, but since these ones are like terms, we have a negative x, adding it with 2 x's. The answer has to be the same as when we have a minus 1 adding a 2. So the answer has to be a positive x. And we have this negative a. So since it has no like term, we just leave it like that. And then we are going to talk about these two like terms. So it's like a b adding with 4 b's. So definitely this is a single b adding with 4 b's. We'll treat it the way we do a 1 adding a 4, which is 5. So we will have a positive 5, but because we're talking about b's, we'll have a positive 5b. And finally, this has no like term, so we just leave it like the way it is. So we're able to add and subtract like terms, and when we cannot do any of that anymore, in this case we don't have any like terms anymore, we have arrived at the end of our simplification. And it's also important for me to tell you that this process of putting together like terms and adding them together is what is referred to as simplification. So when anyone ever asks you to simplify something, what they mean is that you should look for like terms and add them together. So it's like the way you can always write something in an easy way. So if I was to ask someone that, hey, how many cars do you have at your house? And then this person responds, oh, we have a Toyota Corolla, a Toyota Hilux, we have a VW Polo, we have a Mercedes Benz, whatever. You know, this person is not answering me in a simple way. When we are told to simplify anything is just to put it together and give us the simple way of putting it. So this guy answering is just supposed to say, oh, we have 4 cars. That's the simplest answer that I'm looking for. Unless I ask what type of cars you have, but I say how many cars. Don't list the names of the car, just give me the number. So numbers are able to simplify. So simplification is like that. Even if someone is to say 1 plus 1, 1 plus 2 rather, it's not a simple way of writing it. The simple way of writing 1 plus 2 is just to say 3. It's pretty much the simplest way. So 1 plus 2 and 3, the same thing. One is simpler than the other. So we look for the simple way of writing something. Okay, so that's it about like terms, and I can give you an example. For example, if someone is to say simplify 2x plus b plus 5x minus a plus 2b. So someone's to ask you to simplify. So you just have to make sure that you understand what you can do. So here there's a 2x, here there's an a 5x. These are like terms. It means we can regroup them and bring them next to each other. So for example, this 2x can be written here, and the 5x can come next to the 2x. So we have a positive 5x. Now we have handled this one. How about this one? It's a b. We write the b like that. But does it have a like term in the expression? Yes, it does, and it's this one. So we write the positive 2b, but we are also not done because we have this negative a at the end. So we have written the like terms next to each other, and then we can add them together. So these 2x and 5x are like terms and they can add. So we add them the way we add numbers. 2 plus 5, which is 7x. And as well as this b plus 2b are like terms. We'll add them however we add a single thing plus 2 of those things. So it's 1 thing plus 2. So it's 1 plus 2, which is a 3b. And we also have to remember that there's a negative a at the end. So have we arrived at the answer? So to verify whether we arrived at the answer or not, we always check if there is any more like terms left. If there is no like terms, then that is our answer right here. So I will give you some exercise so that you can try it out, putting together like terms and solving them as well. All right, so now that we have understood what expressions are, we should be able to also multiply expressions. So like you were able to see that expressions are simply numbers, they're representing numbers. And if numbers can add and subtract, then expressions can also add and subtract. If numbers can multiply, then expressions can also multiply. So remember the list of expressions that we had. For example, an expression called a, and then we would have expressions like b, and then we would have expressions like 2b, we would have expressions like 3a, we would have expressions like p, like q, like 2q. Some would even go as hard as adding each other, 2q plus 2b as a single expression, like that. So all of these can actually multiply each other, just like the way numbers multiply each other. So let's take a look at how that works. It's quite an exciting process that we're about to talk about. So let's say I'm going to start with a single number and how it works. So let's say 2. 2 is a number, and we have to find a way of multiplying it with a number that is the same as itself. So 2 times 2. Of course, we know that the answer is 4, but what I want to focus on right now is how you rewrite this 2 times 2. So there's another way of writing it, in a way that we can write it as 2 squared, to mean that two of these numbers are multiplying each other. Maybe let's try another number, 3 times 3. It means 3 to the power 2. So the power here only represents how many times the number is multiplying itself. I will use the same, another example, like 4 multiplying itself 4 times. And this is the same as 4. So like I said, the power represents how many times the number is multiplying itself. And this is multiplying itself 1, 2, 3 times. So the power is going to be to the power 3. So we're just rewriting this. So what this should help us with is rewriting algebraic expressions in a way that if you have an A multiplying another A, what you essentially mean in a simple way is just the A to the power of how many times the A is multiplying itself, like 1, 2. So this is A to the power 2. Even if you had a B multiplying a B multiplying a B, I don't know how many times, we're just going to say B to the power 1, 2, 3, 4, and to the power 4 there. So the 4 comes there. So that's how the powers work, and they make our life, as far as simplifying algebraic expressions and multiplying algebraic expressions is concerned, they make it so easy. So let's look at that now in details. Okay, now we are going to dive into something exciting. I'm going to choose an expression. So this will be a bank of expressions. I'll first choose expressions that are a single expression. Let's say 5a, and that's a thingy, and then there's a 2a. Now I want to be able to multiply these two expressions. So let's say now I come here and say 5a multiplying with 2a. What we're essentially saying right here is that this thing we don't know about is multiplying each other. We are also supposed to be aware of one thing, that between the 5 and the a, there is a multiplication happening. Between the 2 and the a, you see how there is nothing here said about the 2 and a? It's like they're glued together. The force that is gluing them together is a multiplication force, which is invisible. Here there's a multiplication force, which is invisible. So it's more or less like 5 times a times 2 here times a. So we'll just put the multiplication just to see it clearly. So, when you're multiplying numbers, I'll just give you an example. When you're multiplying 2 times 5, it's actually the same as 5 times 2. It's pretty much the same. The order does not matter in multiplication. And it's a very important thing for us to know that when we say A, for example, times B, well, it's pretty much the same as B times A, because that's what multiplication does. It does not care the order in which things are happening. All right, so when we have something like this, it also means that we can just put the numbers first. So for example, 5 can come first, and then just the number. The 2 is multiplying second, and then the A, and then the A again. So what we have here is the 5 comes here, the 2 has come here, the A has gone here, this A has come here. So 5 times 2 rather, this 2 here is what leads us to the 10, and this A times A is what leads us to the A squared, because we have the same number multiplying itself twice. So like I said, when it comes to multiplying expressions, it's invisible here. It's present right now, but we can make it invisible. So in a way, 10 times a squared is the same as 10a squared. We will always know at the back of our mind that there's an invisible multiplication right there. So that's how we're going to be multiplying these expressions. And we're also gonna go back. So I'll put this as our first example. And then the second example, we're gonna go back to the bank of expressions and we're gonna add something else. Let's say 20f times a. So we bring it here. Actually, yeah, 20f times a. Let me just write it here, 20f times a. So what we do is just remember that when we are multiplying expressions is the same as just not writing the multiplication and just gluing these two together. Sorry, if you just say f a, that's good. And we just prefer as mathematicians to start with the smallest letter. Instead of fa, we just prefer to start with af. I think it kind of sounds better like that. So now we're gonna have to try our third example. So I'm gonna say 5qr times 8qas. All right. So before we start, we are multiplying, right? And we are lucky that they've written it for us here, but we also know that between the 8 and the q, there's an invisible multiplication, there are there's invisible multiplication. So we can choose to see them if we want. We can choose to put the multiplications where they belong just to see them. And then, like I said, with mathematics and multiplication, a times b is the same as b times a. So if all of these is multiplying each other, let's just start with the numbers. What if I start with the 5, then the 8? So I'm just going to start with the 5 times the 8, and then the letters will come next. I'll start with the first letter that appears in the alphabet for me is A. Then I'll put the A just so that I have an order. A, Q, then R, then S. So when we have 5 times 8, which is 40 for the numbers. So these ones give us a 40. And I can choose to remove this multiplication and make it invisible and say AQRS. And that is our answer. We have multiplied the algebraic expressions. So I'll give you an exercise on how you can do that, and we can give you exercise. Okay. What next now? Next we have to go to the brackets now. Expanding brackets in mathematics. And what is that? Actually, we'll have to go to division of expressions, and then we'll go to the expanding of brackets. And after we're done with the expanding of brackets, we will now go to the Form 3 work that is necessary for us to learn